Hello everybody, I'm your host Shruti and welcome to this week's episode of Sipping Tea with Science. Now we left off last week's episode with an interesting question of whether black holes could allow us to time travel. Well, physicists say that it is in fact possible. We just need to rearrange a few laws, tweak our understanding, and add a bit of applying physics. Let's find out how. Now, scientists say that to create a time machine or a wormhole machine that would take us to a distant galaxy, we would need to have the physics of an advanced civilization. A civilization perhaps millions of years beyond ours. Although time travel has mystified movie audiences for over 50 years, could a wormhole really be used for such travel? Wormholes may lead to things like being able to go to another galaxy by walking 5 feet through a hole, or even traveling through time. But they pose unsettling questions. In the distant future, will Earthlings be able to travel to the past and perhaps even change history? Scientific ideas considered far-fetched today could one day become as acceptable as the fact that the Earth is round. The laws of physics may allow for the existence of wormholes, tunnels providing shortcuts through space as well as time. So could these cosmic subway systems theoretically be engineered into time machines? Einstein's general relativity laws reveal that time travel into the future is in fact possible. His laws show that time is perceived differently depending on where one is in the universe and how one moves. Objects moving at close to the speed of light age slower than static objects, and objects near a gravitating body age more slowly than objects farther away. Clocks, for example, run at different rates in different gravitational fields. The stronger the gravitational field, the more slowly time passes, relative to someone out in space where there's no gravitational field. On Earth, like on the surface, our clocks run slightly more slowly than clocks high up in the sky. So an example of this is that the clocks in the GPS system of satellites run a little bit more quickly than the clocks down here on Earth because they're in a weaker gravitational field. And the scientists and engineers developing the GPS system had to take into account the different rate at which clocks run. If they hadn't done that correctly, the new GPS system wouldn't work. If you were taking a trip from Los Angeles to New York, you would end up somewhere in Massachusetts. Forward time travel has been tested using highly precise atomic clocks. Scientists placed one clock on the ground and sent one in a rocket flying high above the Earth. The two were compared using radio signals between the rocket and the ground. The clocks on the rocket ticked faster. Here on Earth, my clock runs more slowly compared to someone's in a rocket ship somewhere further away from Earth. In other words, their clock is moving more quickly, meaning they're going to the future faster. Physicists have studied whether wormholes could provide travel not only to the future, but also to the past. If there was a wormhole with one mouth near Earth and the other in the center of our galaxy, the rate of flow of time will be different at one mouth than the other when compared to the external universe. But when you look through the wormhole, the rate of flow of time appears to be the same. This difference in their relative ticking rates, as viewed externally versus viewed through the hole, would convert the wormhole into a time machine. That means that by entering a wormhole, you leave here today and come out the other end of the wormhole hundreds or thousands of years earlier. But backwards time travel, or traveling to the past, raises disturbing paradoxes. The most famous of these is the grandfather paradox, which says that if you travel to the past and kill your grandfather, he wouldn't have been able to have your father, which leads to you never being born. But doesn't that mean you wouldn't have been able to time travel in the first place? As we said last week, the topic of time travel and wormholes is a very controversial one, and there are many different opinions from various perspectives. There is still a lot to ponder about though, which I will leave to you guys. We've been looking at quite a bit of science. How about we talk geometry and patterns next week? Until then, stay safe and stay curious. Wait. But before you guys go, I've been doing some thinking. Maybe I'm being too formal in these podcasts. I'm just in high school after all. Bola ma ko jitara local.